First, create a cylinder mesh. I achieve this by creating the vertices of a circle whose radius is equal to the sausage width and whose sides amount is equal to the circle resolution value. I then copy this circle alongside the length as many times as my sausage resolution value. To create a mesh out of these vertices, I go through every point of every circle except the last circle, and make two triangles between that point, the next point in that same circle, and the two matching points in the next circle. Since I want my sausage to be visible from inside as well, I make both a clockwise and counterclockwise version of each triangle. Now that we have our cylinder, we need to scale the radius of the circles in the tips to give it that signature sausage look. For this, we go through every vertex and get the distance to the closest tip. If the vertex is further away from the tip than the tip length, we skip to the next vertex. On the other hand, if it's in the tip zone, we get the progress of how close to the tip it is from 0 to 1, 0 being the tip, 1 being the total tip length. Now, if I were to scale the circle radiuses with this progress, it would be a linear shape, which is not quite sausage-like. So instead, I use an animation curve where the x and y values both go from 0 to 1. Then, I simply use this curve to shape the sausage tip by sampling it at the current progress. Now that I have my sausages, vertices, and triangles, I simply assign them to my mesh, which I do by calling my base class setMesh method. My base class is pretty much a mono-behavior script with the required setup for me to be able to create and render a mesh. And now, without further ado, let's go into the sausage. You're now inside the sausage. How does it feel to be inside the sausage, baby? There's no escaping now. You're part of the sausage is now.